Good afternoon to all and all present here. It gives me immense pleasure to welcome you all to LaunchPad 2026. Today, we have a very interesting relevant topic to explore: White Code, workflow based development with skill as prompts. So, let us make this session an enriching experience by actively listening, learning, and interacting. To formally welcome our gathering and set the tone for today's event, I now invite Ms. Vaishali to deliver the welcome address.
Good afternoon, everyone. It is my great pleasure to welcome you all to LaunchPad 2026, organized by the Department of MCA, SA Engineering College. I warmly welcome our respected resource person, Mr. Prasad PremKumar, Senior Program Manager at Quickplay, and thank him for joining us today and sharing his valuable time and experience with us. I also extend my heartfelt welcome to our respected trustees, principal, head of the department, faculty members, and my dear fellow students. Today's session is a wonderful opportunity for us to learn, interact, and gain valuable insights from an industry professional. I'm sure this session will inspire us, improve our knowledge, and help us to understand the opportunities and expectations of the IT industry. I request everyone to actively participate, interact with the resource person, and make the best use of this valuable opportunity. Once again, I extend my heartfelt welcome to everyone and wish you all a fruitful, engaging, and enriching session. Thank you.
Thank you, Vaishali. Now it's time to introduce our distinguished resource person. I request Ms. Vinisha to introduce our guest to the gathering.
It's my privilege to introduce our estimate resource person for today's session, Mr. Prasad PremKumar, a senior program manager at Quickplay. Mr. Prasad PremKumar is a business professional and a technology expert with 15 years of experience. He began his career as a software developer and progressively moved into leadership and program management roles. He is currently associated with the Quickplay that is professionally focused on encompasses strategies, program management, and operating system. Is interested and professional contributes extended across the areas such as artificial intelligence technology strategy, SaaS, OTT, and digital media. Mr. Prasad completed his post-graduation in business management at IIM Tiruchi. He was ranked first in his batch and was awarded chairperson's gold medal for securing a first rank. He has also demonstrated a strong interest in emerging technologies, particularly artificial intelligence and agentic AI, and regularly shares insights on technology AI, SaaS, OTT, and digital transformation. Today, we are especially fortunate to have him with us to share his expertise on a highly relevant topic: Vibe Code, workflow-based development with skills as prompts. Well, we look forward to gaining a valuable insights from his experience and learning how emerging AI-driven approaches are transforming the way we think about software development and technology.
Thank you, Vinisha. Now I request our esteemed resource person, Ms. Prasad Prem Kumar, to kindly take over this session and enlighten us with his valuable insights.
Thank you. All right, I'm going to switch on my camera for a brief period. Hi, everyone. Connecting from Chennai office. I'm right now sitting in my office. So I've blocked 2 to 3. So we'll try to make use of this time, obviously, for the session, as well as let me try my level best to share my knowledge and thoughts with bright minds. I'm eager to interact with you guys and share my industry experience as well as whatever questions that you might have. So before we jump into the session, some ground rules. We'll start with a survey because I want to kind of have a dipstick understanding of what you guys know about agents and agentic AI or even LLM or whatever chatbots that you guys might be using, and what exposure do you have with respect to using these coding agents for developments. That's one. We'll start from there, and we'll try to dive deep into the workflow as well as skills and prompts, whatever that we would be using eventually for our session as well as for our discussions. So we're almost like 12 minutes into the meeting now. So I'll try to keep it short. I have prepared some slides, maybe like close to 10 plus slides, so won't be much. So don't get bored. Afternoon after lunch. So I'll try to keep it short. But as well as uh, I'm trying to cover it, maybe like 15-20 minutes we'll spend on the slides so that you get some base knowledge. And after which we'll dive into some coding sessions. I'm going to keep it really simple. We'll try to build something so that you can see it visually as well as understand how development happens. Using coding agents. We'll try to build something tangible that you can run it at the end of the build as a product, so that you can also go home and try the same thing with your setup. So that's because um, we have a limited time for this session. So I'm planning something very simple, which we can build in like maybe 15 minutes, and but in a in a tangible manner. It should be a complete product which is working as well, right? So not just the code aspects. So so that's the thing. And whenever you have questions, please do raise your hand. I could see that you guys are having a good time. I could see many emojis and thumbs ups and hands raising. So whenever you have questions, please utilize the chat window. You can share your questions there. I'll try to stop and answer. And also try to, if you have questions that you want to speak out, go unmute yourself. But before doing that, maybe raise a hand so that I'll know someone wants to ask a question or so. Okay. So these are the ground rules. So let me start sharing my screen. I'll go offline now, meaning I turn off my camera to make sure the bandwidth is effectively used for the slides. Okay. All right. I'm going to share my screen. Let's start with the session then. So it should come up in a minute. Would be blurry at the start, but should get fixed up. Okay. So are you sharing? Are you able to see my screen? Give me a S. Okay, perfect. All right, cool. Okay. Thanks to the team for the brief introduction about me. I've been in the industry for close to like 15 plus years now. Like I started with Infosys during 2010, and then worked there for like close to 3 years, and then I moved on to TCS. Worked there for a couple of years, and right from 2015 December, I've been associated with Quickplay for close to 10 plus years now, 11 years, more than 11 years. And I started as iOS developer, and moved on to from an individual contributor, writing code for iOS and iPhone, Apple products. Then moved on to be a Roku device developer, and into project management and stuffs. Now I'm kind of heading the delivery for multiple projects with Quickplay. We operate in globally, so I kind of look after the projects with the US continent, both North America and Canada. So that's pretty much about me. Um, my area of interest, as shared, like recently, I've been after my graduation, uh, after my MBA from IIM. Uh, I've been exploring, or my interest kind of shifted towards AI and business as well. Right? So I'm spending good time on AI. That has given me some knowledge that I can share with you guys today. That's one. And I, regularly write on LinkedIn as well as X. You can see my articles over there. So these are my places where I kind of try to be active socially, professionally on the LinkedIn as well as on X, both. And please do reach out to me. Stay in touch on LinkedIn. We can connect and share knowledge. So that's pretty much about me. I'll dive deep into the session now. All right. So as I said, I'll start with a survey. I want to do a dipstick and understand what you guys know today and what you will be learning. So here is the survey link which I've shared with you. So you guys can access it. I'll briefly stop sharing my screen. You guys can access it. Give me a thumbs up if you are able to access the link. Okay, perfect. You guys can go ahead and answer these two questions. Very simple questions. I'm just trying to understand what you know about today's topic and how familiar are you guys. So I'll give you a minute, just a couple of answers, right? So let's make it quick. Yeah. Okay, I'm seeing responses coming in. Okay, 10 responses so far. Quick. Let's close this and get into the next set of discussions. Yeah. So these are the stats. 20 responses so far. Okay, I'll wait for one more minute and then we'll get into the session. Any more responses? 27 so far. How many do we have? I can see close to 80 people are on the meet. Let's hit at least 50%. Let me see 40 responses. Twenty-eight. Okay, all right. Given the time we have, so let's dive into the discussion. So this kind of tells us, you can see, except augmented LLM, all the other terms are kind of fairly familiar with you guys. RAG, yes, I understand. It's an industry term, so not that familiar among the students groups. Okay, and yes, moving on to the explainable part. Majority is none of the above. 43%, close to 14 people. Agentic AI and agents. RAG is very less. Augmented LM is also less. Prompt engineering, yes, that's the basic. So okay, good number. 40%, close to 13 people. All right. Okay, I'm going to go into the session now. So we will try to look at. Yes. 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 Anyone has a question? Mm, okay, all right, I'll continue. Okay, we'll look at all the the terms that we were just discussing on the survey, right? So that's how the agentic AI or Gen AI has evolved in last 2 years, I would say, right from 2023 or 2022. That's when we started. 2023, I believe. That's when we started witnessing the first chatbot from OpenAI, ChatGPT, right? So, and then that was the very early LLM, large language model, okay, large language model, and then it evolved into next series of things. So whatever that topics that I've asked for, right? So that's the evolution from LLM to augmented LLM, and then to prompt engineering, and then to RAGs, and then to agent, and then to agentic AI. So we'll briefly touch on what all these mean. So I'll try to, maybe cover this in next 15 minutes, targeting to close this by 2:45, so that the remaining 15 minutes, let's try to build something, and I can, the last 5 minutes, maybe I can park it for Q&A session. All right. So, okay. So what is a plain LLM? LLM meaning large language model. There's something called a small language model as well. So all these are part of a larger domain called AI, artificial intelligence, and AI ML, machine learning. Okay, so a model. When I say a model, it's nothing but a set of. It's an architecture, basically a neural network enhanced architecture, which, in very sense, at a bare minimum, can predict the next word. That is the minimal or a standalone thing that a language model can do. So that's what it is. Whenever you hear about a large language model, all it can do is you can query it, and it takes your query, and it just gives you an answer. Okay, so it is nothing but it just predicts the next word. It always does a prediction for the next very good word, and then that's what you're seeing as a response. Okay, so that's the very minimal. And having said that, you might have interacted with ChatGPT or Claude or other similar Gemini general agents. Okay, so those are agents, not just LLMs. Those are agents, meaning it can understand, or it can whenever you start your session, or you interact with the general agents, it understands the subsequent question. For example, you first ask one question, or you start with first question, and then it gives you an answer, and then subsequently you might ask a next question. Okay, but the agent will respond to you in a way that you are, as if you're talking to a person who understands the previous context as well. But that is the functionality of an agent, and a basic LLM cannot do that. So in that state, it is stateless, meaning it does not remember anything. Think of it as just a simple function or a program. When you give your query as an input, it gives you something as an output. That's it. Okay, and it does not have any external tools available to it immediately. Nothing of that sort. As a bare minimal LLM, all it can do is it can accept a user query, and it gives you a response as a message. That's what it is as a bare large language model. Stateless, and no tools are available. The knowledge what it has is based on the training that was provided to the model. For example, some models, when the early ChatGPT came up, it was trained till 2021 only. Okay, so if you had asked something about the current affairs, what was happening during 2023, it had no knowledge about it. So it can only respond whatever knowledge that it captured during the training period. So if you ask anything that's out of the knowledge, it's like out of syllabus or out of scope for it. So it would start hallucinating, meaning it would throw you some garbage. So that's the basic very LLM. Okay, and next part is augmented LLM, meaning you are trying to give some additional tools to the language model. For example, uh, uh, by tools, I say it can be a separate resource outside the language model, meaning think of a model which wants to access a document that you have separately. The document could be a Word document which has some information, let's say, about a project, a specific project. The Word document has all the details to it. Okay, but this information is contained only within the document. And if you're going to ask the LLM model about this document, obviously it won't have any knowledge about it. Okay, but the way you want to interact with the solution or whatsoever you're trying to build, you want this LLM to understand the document, and then you can interact with it, maybe enhance the document or work on the whatever contents that is available in the document, right? In order to do that, the model has to first understand the document, right? But to understand the document, you need the model should know where to access it first of all. Maybe you can just drag and drop the model, right? But how to access it? If you think about this deeply, let me take you to this. I'm going to switch back and forth here. So this is the tool call. When I say a very bare minimal LLM language model, this is how it would be. So you can see the message, which is role as user, and content is nothing but is your query. So the question is like, what's 47 into 12? That's it. So the response is model just gets this message and then it would give you a text. It could be possibly wrong as well, because initially the chat GPT models were only predictors, meaning 47 into 12, it tries to predict, it does not perform the actual multiplication. You should understand this aspect. Okay, the very initial large language model, it's just a language model. It does not know about mathematical multiplication or any other tools. So now, in order to make this understand that this is something about multiplication, and the LLM has to invoke a separate function, for example, multiplication function, which accepts two numbers, and then it gives you an output. Okay, if you write this as a separate function, the LLM should invoke that function and then get the response, right? So that's how it works in the real world. Okay, so this is what it is. Tool calling is, it just throws you the response, because LLM cannot actually make the multiplication by itself. So what it does is it just says, please call whatever is the name. Right now, this is the uh, open PR is nothing but I had a repository which I was working on. So let me change this. Think of it as get multiple, and maybe we can have A equal to, similarly B equal to. So this is how it would be. Okay, so because LLMs can only understand text, and it can spit out text, that's it. Okay, so what it would say is just uh, gives you the response, please call get multiple. Okay, your program or your code has to understand this means that this is a tool call, and then should make the appropriate function call, get the response, and feed it back to the LLM model. So that is how it internally works inside an agent. Whenever you now you can understand, whenever you ask ChatGPT or Claude or Gemini your question like what's 47 into 12, this is what happens behind the scene. The LLM throws out this response saying please call get multiple or whatever is the function underneath that has the actual tool multiplication. The multiplication method is actually invoked, and the response is again fed back to the LLM. The LLM reads the response, processes it, and then gives you as the final answer. This is how it works. So this tool, the additional function or a program or a method, method or function, whatever you call, right? So those are the tools additionally given to the LLMs. So these are nothing but augmented LLMs. Okay, and so one augmentation is tool, the other one is memory, because the previous slide I said it is stateless, right? Meaning it cannot remember anything. So you need to have a separate memory. It could be a database, or it could be anything else. It could be within the model or outside the model. So all these could be orchestrated. So that's the memory part. And similarly, retrieval. Retrieval meaning, as I was saying with the document example, when you have a lot of information with the document, which is kind of private to you or confidential to you, and it is not available openly out in the wild. It's not available on the internet. Okay, think of something of this case. In this case, you want the LLM to read the document and then understand it and then interact with you, respond with you, and work along with you, right? So in those cases, whenever the LLM answers any question that is related to the content that is with the document, the LLM's answer should be grounded with facts that are available in the document. Meaning, it cannot just hallucinate. It has to like read the document, understand, and respond to it, right? So that mechanism is called as retrieval, RAG, which is retrieval augmented generation. So technically, there's a bit of things involved. We'll dive deeper into it when we hit that slide. I have a separate slide for it. Okay. So these are possible augmentations. One model, three augmentations: tools, memory, and retrieval. So that's about augmented LLM. So now tool calling, which I kind of covered with an example. So now grounding answers with RAGs. So this is what I was saying. The other thing that you have to understand, what I wanted to share here is, again, think of a PDF or a Word document, but what if it's like it contains hundreds of pages, or 500 pages, or 1,000 pages? Like, what if a book, right? If you're trying to feed this complete book or a complete PDF to the LLM, it's quite a lot of information. Okay, and also there could be quite a lot of overlaps. For example, think of the scenario where whatever textbook that you use for your study, right? Maybe whatever semester that you are into, and pick one large textbook, whatever that you have. Think that if you're going to give this textbook as a PDF to the LLM model, it cannot understand that, or it would start hallucinating if it tries to like read the complete passage, because the LLMs also have limitations with respect to their context. Meaning, it can think of it as something like a RAM for a computer. So it can only load certain things into its own brain. Okay, so 500 pages, 1,000 pages is like too much. Okay, and it cannot it cannot give you the exact answers if you're going to ask about, like, okay, what is what are the concepts of hoops, if this is going to be a question, and the book that you have is like hoops and data structures, say, the LLM would start to like hallucinate. Okay, because it has to like uh, go through all the contents and understand, have an understanding of it, right? So that's not the efficiency of that is like very low. So the answer for that is RAG, which is retrieval augmented generation. So what technically happens here is, we have a separate model which does the embedding. Meaning, when you give these text as inputs to this model, the model embeds it. Embedding is nothing but it. Think of it as converting a text into a number form. Okay, and finally, this number has a special meaning in the in the 3D space. So every word will have a special meaning. For example, Apple has two different meanings. Apple could be a technology company, and the other meaning could be Apple could be a fruit, right? So in this way, depending on the sentence, apple is red. So this means that it's a fruit, right? So Apple shares have come down, or it has gone up. So this means it's a company. So this knowledge kind of gets embedded into the model, and it finally creates a number which has a special meaning. Okay, and this number is available with the embedded databases. There are many vector databases which actually do this embedding. And when you retrieve it, the way it works is, let's say what is the share value of Apple today. Uh, so we want to get this information from the embedded model. So what would happen underlying is that your question will also be converted into a embedding, meaning it would also be changed into a number, and this number is used to perform a search on the vector database. Okay, and the response what you get is going to be a number again, which will be retrieved, and is the synthesized text is given back to the model. Model tries to understand the response and then gives you as an answer. So that's where this retrieval augmented generation tries to solve the hallucination, as well as grounding the answers on facts and documents, because LLMs cannot just throw or make up things, right? So that's where this retrieval augmented as generation has come up, and this is quite a hit because it kind of solves so many problems that LLM has. So that's about RAG and agentic loop. So, in fact, I'm very sure that many of you or all of you have, are, interacting with agents on a day-to-day, maybe ChatGPT or Claude or Gemini or whatever. Okay. So the agent that you're interacting, right? So that's an agent by itself. When you ask a question, it takes your question and it does some, reasoning, and then it responds back, right? But compare this with a minimal LLM, meaning bare minimal LLM, which can only accept user query and gives you a response, right? Because at the very minimal level, it can only do that. But how does this agent work then? So the answer is there is an underlying loop which is running within the agent. So that loop is nothing but react loop, meaning reason and act. REACT, reason and act. So what it would do is, whenever you ask a question, it tries to reason and it tries to take actions. So that's the differentiation here. An agent is capable of performing actions. The agent is capable of making decisions. That is what differentiates an agent against against a bare metal LLM. So that's the difference here. So what you need to understand is this is the core concept. So LLM and tools are orchestrated through predefined code paths, meaning there is a programmatic loop which is running, and it tries to get your question and get the response from the LLM, and the subsequent question what you provide is added to the previous question, and the response of the previous question is also retained. So think of it as chain of thought, meaning first question, first answer, second question, second answer. That's how every time this is concatenated, or this is compacted as a single conversation, and then it is given to the model. Because every time you have to give the complete conversation to the model, get the answer. That's how it understands your previous messages or previous questions and answers. That's how it understands or retains the context. This is no magic, okay? Because at the bare metal, you can only give a query and get an answer. So let's say you have conversed with the agent with 2 3 turns. Let's say you are now asking or prompting for the fifth time. So all the previous four prompts, the answers will be combined when you make the final fifth question or fifth prompt. So that is provided to the LLM and answer is retrieved. So that's the magic here. So it's actually a programmatic loop. Okay, and so now add tool to this. For example, when the agent or the LLM replies saying, "Okay, this is something I need to make a tool call," then you will see a tool response, and then you have to make the actual tool call, get the answer, give it to the LLM, process it, and then get the answer to the user. So this is how it works underneath the loop of agentic loops. So that's what you need to understand about agents and loops. Harness. So the harness is nothing but the structure that is around this, built around this LLM. Because as I was saying earlier, LLM as a bare minimal or the basic unit is it's just an API or interface where you can ask a question, you will get an answer. But in order this to work as a agent or a conversation bot or a chat bot, it needs memory. It needs to retain its state, and it needs access to the tools. Maybe like it may need access to the browser, and and maybe it needs access to the internal resources, etc. Not just that. Uh, uh, um, there is also something called as system prompt, which sets or gives a predefined agenda to the agent. Meaning, you say that you are an experienced marketer, and your tone is must be a professional, and you know your whenever a user asks a question, you work in this manner. So these kind of instructions might go as a system prompt. Not just these, there are some guardrails as well. Guardrails are nothing but, think of it as rules that you give to the agents, because agents, if without any guardrails, can go haywire. Okay, because it can make its own decisions. You need some control over what it can do and what it should not, right? Mainly the do's and don'ts. So all those are given as instructions, sometimes with the system prompt by itself, sometimes outside the model also, before the actual question reaches the model. Okay, so that's about the guardrail. Compaction is nothing but, let's say you have like spent almost 30 minutes conversing with an agent. So now think, when you started, it was the first question. And now let's say you're almost like done like 30, 40 turns, meaning you have asked 30, 40 prompts, and you have received responses. So now the 41st prompt, whichever that you're going to ask, within the same session of the agent, would contain all the previous 40 prompts as well as the responses. So this is so huge now, right? So there is quite a lot you would have discussed, and back and forth would have happened, and the information is quite huge, and there is a limitation with the context of models as well. It cannot keep on, getting information, right? So it would start hallucinating if if we exceed the context limit. You might have seen this with Chat GPT, GPT, and Claude or other models. Nowadays, these models have auto compaction, meaning whenever it reaches 90% or 95% of the or even 100% of the context, it tries to like compact, meaning it tries to compress or compact the previous conversations and retains only the required information in its context, and then continues the conversation. So that's nothing but compaction. Finally, agentic AI is nothing but, agents can make decisions, and it can make tool calls. That's what it differentiates from a bare metal LLM, as well as a routine a simple program, because it has got some intelligence, right? So it can reason, and it can make some actions. So now think of a agent managing many sub agents. So that is nothing but agentic AI. One use case that is very prevalent in the industry is orchestrations, meaning you have a routine work which is done by different people, and nowadays those routine works are getting automated with these agents. So different agent does different job, and there is a supervising agent which manages these sub agents. So that's the uh, thing about agentic AI. So that's pretty much all I have done is like, we have just grazed at the grass level. Okay, I've just introduced these topics to you. So I would urge, explore further and read on this. Maybe understand whenever you interact with a chatbot, or whenever you interact with a Gen AI, understand, try to like think what happens behind the scene. So that would help you or cement this knowledge much more. Okay, so so it's almost 2:46 now. So I'll jump into the demo, and then we can come back to our discussions and uh, Q&A session, and then we can try to close this. Okay. Perfect. So now let's do some bit of coding. So this is where you will see the skills as prompts thing. Okay, I've switched the tab now. Is my screen visible? You would be seeing my terminal or something similar to DOS prompts. So give me a thumbs up when it is visible. I think so. Okay, perfect. Okay, so what I'm thinking to build is, okay, right now this is the folder that I'm in. I'm on a MacBook. Okay, so what I'm trying to build is, or what we can build today is, I was giving quite a thought about this, and we need something to be built within 10 minutes or like 5 minutes, right? 5-10 minutes. That's the time that we have, but we want something as a finished product. Also, we need to cover different skills or different workflows that usually happens in a software development cycle. So you might have read about already read about SDLC, software development lifecycle, right? So what generally happens is like some team does the requirement gathering, meaning we normally in the IT world, normally the product team does the requirement gathering. They go sit with the customer and they have a discovery session, back and forth discussions, and they try to like interact with them, interview them, get all the requirements, and then produce a Word document. And you might call it as a requirement document, BRD, business requirement document, which is nothing but a Word document which will contain all the requirements, both functional and non-functional. Okay, and this is the first stage, and then this requirement would be broken down into a high-level design and a low-level design, which would now contain technical things, meaning it would what is the architecture of the application, and starting from there, like what tech stack is required, and for the front end, for the middleware, for the back end, front end, like what JavaScript tech stack or React language or Angular or whatever, right? So that needs to be decided. And similarly, middleware, what is going to be your language over there, what is going to be the stack and security, how are you going to communicate, what are the APIs, back and forth responses and everything. Similarly, backend, what database if required, and what are the APIs and everything. So all these are technical things, architectures that needs to be, the complete system has to be architected, designed, and then is given to the you will arrive at a couple of documents: high level HLD, high level design document, and the LLD, low level design document. And then you will give this to a development team, which starts getting these requirements and starts developing it. Okay. And finally, during the development, you will also need to like do both development testing, and once the development is complete, you will do a final QA testing, quality assurance validation as well. So once this is completed, you have the final product. Okay. So this is how generally, mostly this is what is happening in the industry right now. This is the workflow. Okay, and but this has changed now. Like this used to be the waterfall model, but nowadays agile and hybrid methods are used. Meaning we follow a sprint model wherein every 10 days you are supposed to produce some output, and it is built in an incremental manner, meaning MVP plus one plus two. That's how it is. Minimum viable product, MVP, something that you have. Think of it as you're trying to build, make a cake. The first MVP could be what to say, a small piece of cake which is edible, not just a cut on the bigger cake. Okay, it's just think of it as a muffin or something of that size, small. Okay, and then you add the next layer, and then you add the next layer. That's how you keep building it and finally arrive at a big cake. This is what is MVP style development, or the sprint or the hybrid style development. That's what happens normally in the industry right now. Okay, so I've explained you the workflow. So now let's try to dive deep. See a demo on how we can build something similar to this. Using coding agents. Okay, so I'm on this terminal uh, within this folder. So what I'm going to do is let me first create a folder as demo. You can see this folder that's created. Okay, I'm inside the demo now. So I'm going to go into demo folder. So this is the agent that which I'm going to use now, Copilot. We use in our at least in our company we use GitHub Copilot as the assisting coding agent for our development works. So you will see you'll see the stark difference, because during my college days I learned hoops and C++, I believe, 26, 2000, sorry, 2007, at that period. Okay, so that was the language that was taught with, to me at least, during that period. And we had to remember the syntax, remember the, constructs, language, and everything. But now you will see that things have changed. So, okay, so I'm inside this GitHub Copilot. So I'm going to use a set of skills as prompts. I'm going to not do a prompt here, meaning I'm not going to give an entire prompt and then start building it. You will see the things, whatever that I described as requirement gathering and documentation, designing, and development. You will see all these happening, in a short-circuited manner in just 5-10 minutes. Let's get started. The skill that I'm going to use is like this is a open source skill, Matt Pocock skills. So I'll introduce this to you as well. So this is an open source skill. You can go here, skills for real engineers. It's an open source one. Okay, so these are nothing but workflow based skills which you can use for your development work. So there are many skills like this, but I love this one. It has a grounding on the engineering concepts. It does a very good breakdown of requirements and even the test driven development and things. So this one. So okay, now getting into it. Hope the text is visible. I wanted to just make sure the text is visible. Give me a thumbs up so that you can see the text. Can I see? Perfect. All right. So what I'm trying to do is I'm trying to set up these skills. Um, so what this basically does is it tries to like understand this empty folder, whatever that I have here, right? This empty folder, and it tries to right now it is empty. We are trying to set up. Think of it as basic setup that you want to do within the folder. Once these files are created, I will open that folder and will show you what is the structure and everything. Okay, so that's what is happening right now. So with a agentic setup, project structure, that's what it is. So you can see the agent in work, and then it tries to like do the working, creating the files and everything. So it tries to make a directory, list down what it is there. So you can see docs folder has been created automatically, and it is trying to like create all the other files within the doc folder as well. I think I'm going to shoot definitely over 3. I hope that's fine, right? Shankar, is that okay? Maybe I'll consume 5-10 minutes extra after 3. All right. So these are files which are getting created. These are MD files, markdown files for the basic, setup. So you can see this is done here. So I'm going to open this folder in Visual Studio Code, VS Code, which is nothing but an IDE, integrated development environment. So it's again an open source one. It should come up in a minute. Perfect, it's here. Okay, I'm going to trust this. Close it, close it. Close it. So you can see, so these are the 4 files which got generated as very basic setup instructions saying this is for agent and we will triage issues with labels and some domain related contents, basic things. So think of it as just the project structure setup. Okay. And whenever the agent reads these documents, it has some understanding of what is basically happening here. That's the thing. So now let's dive into this. Now I'm going to do grill with docs, which is nothing but a skill which will basically do the requirement gathering. Think of it as that simple. So what I'm going to build is um build a single page snake game with increasing levels and increasing speed. Okay. Maintain high scores for each for game sessions. So I should say maintain high scores across, because we want to, let's say we want to have whatever is the last high score um maintained that was scored should persist. Okay, so this is quite simple. I'm just trying to build a one-page snake app where you might have played this. It tries to eat the food and then grows, right? So that's the one-page single app. So now what it does is I'm just giving it as a input. So grill with docs is one of the Matt Pocock skills. It tries to like ask me questions. So now it says it tries to understand what is that I'm asking, and then it would prompt me with follow-up questions. So let's see how many questions. Normally, like 5, 10, or based upon the complexity of your requirement. So it tries to understand and break down the requirements and finally tries to document it. So we'll see that into action. Okay, so now here's the first question. Single page, should this be a static HTML file with vanilla JSS? Yes, of course. I'll say yes, because if you have other answers, you can go and give your requirement here. So let's choose, let's have it very simple. HTML file, vanilla JS, CSS. That's it. And no build step, just a static file which you can just open and play. Okay. And next question: how should the game board be rendered? HTML5 canvas or a DOM grid? For gamings, canvas is recommended, so I'm going to just say HTML5 canvas. So I'm just selecting, giving that input. Next question: 2020 grid or 20 pixel cells? Okay, this question is about the design. Like how should the view look like? How should be the how many? What is the size of the grid and cell? So it's recommending 20 by 20 and a 400 by 400 pixel canvas. So I'm accepting it. Um let's see what's the next question then. What controls do you have? Okay, yes, very good question. So now we want to interact with the game, right? So it recommends arrow keys, up, down, left, right, and then WASD is nothing but the literal keys WASD on the keyboard. Okay, so or only arrows only or WASD only. So I'm going to say both. Now you can think of the magic that's happening behind the scenes, right? All these literally used to be a person work, interacting with the customer. Okay, now these agents are like, very good enough to like understand and collect these, post these required correct questions. That's the evolution or development with the agentic AI, or I mean Gen AI models so far. Hitting, okay, what happens when the snake hits the outer wall? Whenever it hits the outer wall, yes, let's have the game ended. We don't want it to like pass through and come through the other side. So let's end the game whenever it hits the walls. Okay, what should trigger a level increase? So level up every n food eaten, meaning every 5 food. It says whenever the snake eats or ate 5 foods, you go to the next level. That's one option. The next one is level up based on a score threshold. Yes, maybe based on what score you are. We can, once you reach a particular score, let's say 100, and then you go to the next level. This is also fine. And then similarly, level up based on elapsed time. How much longer you last in the game, based on that you can go to the next level, right? So I'm going to keep it very simple. Let's have it as 5. And how should speed scale with level? Increase speed by a fixed percentage each level. Cap at max speed. Yes, I'm going to choose that. uh, that's a good one, simple one for this demo. And concrete speed curve, starting tick interval per level decrease, and what is the cap. So it is suggesting like every what the question is basically, if every level increase, what should be the incremental speed levels per level, and what should be the max. So I'm going with the recommended one. So you can think and understand, like I just gave one sentence, like I want to build a snake game. Okay, it was able to do its own research and then come back with all these questions. And okay, here's the next one: how should score be calculated when food is eaten? Flat plus 10 points every food. Yeah, let's go with it. And should higher scores be single best score or leaderboard or top in score? Whatever is the recommended one, I'm going to go with top 5 high scores. What should each high score entry record? Just the score value, yes, that's enough. Because we have already shot ahead of the allocated time, so I'm trying to keep it simple and then move ahead. So what should happen when the game ends? Overlay shows final score. Yes, let's proceed with it. So, okay, hope you're here. What should the game support? Yes, game should support pausing using spacebar. Perfect. So it has asked all the all the questions, and it has given me the summary now. So these are the summary of decisions that we have made now. So and now it's asking me like, does the summary match your understanding? If yes, I'll write the context.md file and 2 ADRs. So I'm going to say yes. So now you can see the same things happening here. You will see all the document that is getting generated. Okay, maybe I closed it. Okay, retry writing. Perfect. So it is creating the file now. And yeah, here it is. You can see the context file. And yes, yes. So these are nothing but, if I show you in this way, in a readable manner. So this is trying to write about the game. That's the context. And it tries to create other files as well. So yes, it has done. And also we have a couple of ADR documents, which is nothing but the requirement document, which is done. Okay. And now it is suggesting, uh, It has locked in all the requirements and it is suggesting now just say the word example implement or so let's try to implement this now. So I'm going to give the ADRs. So you could see that we just kind of did a quick requirement gathering, and whatever that was collected as information has gone into these documents, and this document I've given it to a agent to start implementing it. Okay, so that's what we are seeing now. So these are implementation related questions which I'm answering quickly given the time. Yes, yes. So it is basically trying to create a Git repo, and then it tries to create the required files. You can see that on the left now I have a source file, SRC folder, and I have also a test document, and it has written the tests first. So it is following a test-driven development, so that tests are written first, and then it tries the actual logic. Crazy, right? You can see how smart it is. Okay. Okay, so now we can see the source file is getting populated. You can see this logic compute score. So it is generating the code. The beauty is like you can I have been through a decade in the industry, and I've been at a place where a particular developer is identified using the language that he knows. Okay, because I right now like been through like more than a decade now. Like I can say like I know more than like 5-6 languages. But think when you start as a student, and then the first languages that you learn, the programming languages that you learn right with your curriculum, and then you move into the industry, and then you might be required to learn other languages, right? So but the thing is that has kind of completely changed now. Okay, if you ask me, should someone still worry like what language to learn, or should this completely be offloaded to the agents now, because agents are completely generating the codes? Should someone even understand or care about it? I would say still yes. At least you need to understand or have the capability to read the code and understand the logic. You may not have to like remember each and every syntax of every language. That's not possible, because there are numerous languages, n number of languages today. So I don't recommend that, learning a different language, but rather you should build the skill and capability to read the code and understand the what is the logic is there. And because even in today's industry, we do not let these coding agents to completely ship the product. There are human in the loops, meaning it does generate the code, and likewise I say yes or no. You can see, right? It asks me a question: should I do this? Yes, because I still am the person in the loop in the build process. Trying to like look at is this okay or not? Should I change it? And all these are still there. So in order to bridge that gap, you need the skill. You need to understand what is the question that the agent is asking, and is this what I want to do? And is it you should have your own decisioning. You cannot, even though the work can be outsourced, but decisioning is still with humans. So you should remember that. Probably that's the takeaway of this session, I would say. Okay, so it is trying to build the code as we speak. You can see now, initially it was just this game logic, just
Yeah,
two,
can
three
I cut
lines.
பண்ணாத?
Now, like, quite a lot now, right? Mm. So it's trying to build the complete JS logic. So this is how, in fact, the code generation happens, and in fact, it does the testing part as well. You can see the test logic that's getting added here. It is trying to add so many test cases and validate all possible things. So I'm going to park here, and so meanwhile, because I don't want to go beyond the allocated, I mean, we have already shot the time, but what I can show you is like I did something prior to our session. Uh, where I have this. Okay, I have this already. I kind of tried this today morning, when I after reaching the office. So I'll show this, open this part uh, here. You can see it has these similar. So that it's the same thing, in fact. So tests, docs, and it has this index.html. Okay, so now I can just show you like I'm going to. Just a second. Let me reopen this one. Okay, I'm going to open this directly. You can see, so I can interact here. You can see this what's developed in just 5-10 minutes of work. So complete code generation by a coding agent. So yeah, that's pretty much I wanted to show you guys, like something that I can build, but given our time, I'm exceeding the time. So let me pause here. Um, but that's the thing that I wanted to cover. Um, okay, I'll go back to the slides. I'll just wrap it up quickly. So here is where we left, right? So this is the recap. We started with what is a bare, very minimal bare metal LLM, which can only get a user query and then gives you a response, and it has no state and no memory, nothing. And we moved on to talk about augmented LLMs, where you provide tools and memory to the agent, I mean to the model, and how you can retrieve facts from a document, information from a document and stuffs, thereby touching upon retrieval augmented generation (RAG). And then we moved on to talk about the agent loop, React loop, what actually happens behind the agent, behind the general chatbot agent that you see in ChatGPT or Cloud or whatever, right? And then we touched briefly on harness, which is the structure that is around the LLM with the system prompt, guardrails, and compaction stuffs. Finally, we touched on agentic AI, which is nothing but orchestration of different agents. So that's the recap, and the next steps for you, like from where you can go, is like try this on your own, maybe with Claude or Gemini or whatever coding agent that you are familiar with, and try this skill, Matt Pocock skills, that's available on GitHub open source. You can install the skill and maybe try the workflow based development. This information is quite a thing. You can go through and look at each the skills, what it means and what it achieves. So thereby, if you want to like build something, you can try give your hand, like same try building the same snake game or a ping pong or whatever, or whatever that you love building, right? So that's the end of this session, team. Um, do you have any questions? I can maybe spare 1 or 2 minutes, answer them. No questions? Can you please share the GitHub links? Okay. Yeah, I can. I'm seeing it. I'm seeing it. Oh, it's. I'm sharing it right away. Here it is. It's an open source skill. I mean, in fact, the person is quite a knowledgeable person in the industry. He has his own YouTube channel as well, where he's talks about the skills what he has developed. Okay. By the way, skills are nothing but pure MD files. It's just a markdown file which gives instructions to the agent how to operate, how to work. That's it. For example, think of you're going to teach the agent how to make a coffee. You'll just write the instructions, right? Step one, heat the milk. Step two, add the coffee powder. Step three, add sugar. That's how. These are instructions. When you write these instructions in a simple MD file and name that file with a specific format and follow a structure folder, that becomes a skill. Okay, so every agent has a specific skill structure. Now it has become standardized. That's how you create a new skill and give it to the agent and ask the agent to use the skill and then work. That's how it is. Okay, next question. All right, then I think it was great sharing whatever that I could. I hope that these were new to you people. I mean, new to you guys, and then you would try it and maybe share what you learned on LinkedIn. Post share it with me or ping me. Happy to know that it added some value. You learned something today. Yeah. Thank you. Thanks, everyone.
Thank you, sir.
Yes.
Thank you so much, sir, for the extremely insightful and engaging section. As we come towards the conclusion of today's enriching section, it's time to express our gratitude. I now invite Surya Prakash deliver the oath of thanks.
Good afternoon, everyone. It is my privilege to propose the vote of thanks for today's insightful session, Whiteboard Workflow-Based Development with Skills and Prompts, organized by the Department of MCA as part of LaunchPad 2026. First and foremost, I would like to express our sincere gratitude to our resource person, Mr. Prasad PremKumar, Senior Program Manager at Quickplay, for sharing his valuable knowledge, experience, and insights with us. The session was truly informative as we gained valuable insights into large language models, RAG, AI agents, RNS, and agentic AI. The session helped us understood these emerging technologies and the role in shaping the future of AI and software development. I would also like to extend my heartfelt thanks to our college management, principal, head of the department, faculty members, and all the coordinators who made this event successful. A special thanks to all my fellow students for actively participating and making the session more engaging and meaningful. Once again, I thank Mr. Prasad PremKumar for this wonderful and informative session. With this, I conclude the vote of thanks. And I have a kind request all the students to kindly fill the feedback form. Thank you for everyone and have a wonderful day. I have shared the feedback form link at the chat, so kindly fill the feedback form. Thank you.
All right. Thank you. Thanks. Happy learning. See you some other day. Bye bye.